Professor, my name is Nitinsai Karuturi. This is my midterm progress report for my project. My project is about recognizing military vehicles in radar images, and here I'll walk you through my work so far. So, coming to the agenda, my report covers 4 sections: my literature review, image processing pipeline, my baseline model results, and the challenges I ran into and how I fixed them. So, coming to condensed literature review. For this, I have reviewed 4 papers that directly shaped my work. First, the Lee filter from 1980. This paper explains how radar noise works and how to remove it. I used this as my very first pre-processing step. And second, a con made by Chen and others from 2016. This is a small CNN designed specifically for M-star radar images. I used it as the blueprint for my own network. And third, the CFAR paper by Rohling from 1983. This gives a method to separate a target from background clutter in radar images. I use this as my second pre-processing step. And the fourth one is vision transformers. I read about this one but did not implement it. It needs a lot of training data and heavy computing power, which I do not have, so I kept it only as background context and for the reference purpose. And coming to my pipeline overview, my pre-processing pipeline has 4 steps. Step 1 is the Lee filter, which removes radar noise. Step 2 is CFAR segmentation, which isolates the vehicle from the background. Step 3 is morphological cleanup, which removes any leftover noise pixels. And step 4 is cropping image to a fixed 64 by 64 size. This is real domain engineering, not just basic augmentation. And this is my pipeline demo. Here you can see real radar chips going through my pipeline. On the left you can see a chip before and after the Lee filter. The background becomes much cleaner while the vehicle stays bright. On the right are sample chips from all the 3 vehicle classes, which are BMP2, BTR-70 and the T-72. They all look like bright blobs on a dark background, which makes classification challenging. So this is HOG plus SVM baseline. For my classical baseline, I used HOG features combined with an SVM classifier. HOG captures the shape and edge information from each chip, and the SVM learns to separate the 3 classes. The result was 91.4% overall test accuracy. Here, T72 scored the highest at 99%, the BTR-70 got 89%, and the BMP2 got 86%. The main error is BMP2 being confused with BTR-70 because both are wheeled armor vehicles that look similar in radar images. So this is the initial CNN. My deep learning model is called SARNet. It has 3 convolutional blocks followed by 2 fully connected layers with dropout for regularization. I trained it for 10 epochs of CPU. The final accuracy was 90.1%, which is slightly below the classical baseline, but this is completely normal for a small dataset at early training. The model peaked at 95.6% at epoch 9, which tells me that more epochs and better turning will push it higher. And this is my confusion matrix. Looking at the confusion matrix, T72 is classified almost perfectly in both models because its tank shape produces a very unique radar signature. But BMP2 and BTR-70 are the hardest to separate because both are wheeled armor vehicles with similar shapes. This is a data challenge, not a model failure, and I plan to address it in the final stage. So coming to the roadblocks and the pivots, I faced 3 main challenges here. First one is training on CPU was too slow at 45 minutes per run. I fixed this by reducing image size during testing and only using full size for the final model. Second, the dataset labels were organized by serial numbers, not vehicle names. I resolved this by using a pre-labeled version from GitHub. Third, my CFA threshold was not consistent across different chips. I switched to a percentile-based adaptive threshold, which worked much better. And coming to my final summary and midterm progress. To wrap up, my pipeline is complete. HOG plus SVM achieved 91.4% and my CNN achieved 90.1% at 10 ports. For the final presentation, I will run my hyperparameter tuning, add an attention block to improve BMP2 and BTR70 separation, and produce a full comparison table across all the three pipeline variants. So this is all about my midterm progress on my project. Please do let me know about any feedback I have if I'm doing any wrong or I have any feedback. Thank you, Professor.